All right, today we are looking at lesson 9.2, and we're going to be solving the equation ax squared equals b. So this is the same equation we were looking at for parabolas. If we put it on a graph, that's what we would see. But we're going to look at actually solving it. So doing some algebra, talking about square roots and how there's a positive and a negative version of all square roots. So your big idea, when b over a is not 0, then the equation ax squared equals b has two solutions. X equals square root of b over a, and x equals the negative version of the square root of b over a. So where in the world is this even coming from? So if we come up here to our equation, and you wanted to solve for x, and you wanted to get it by itself, you would divide by a to get rid of it. So that goes away. So you're left with x squared equals b divided by a. And then if you want to get rid of a squared, you square root, right? So this becomes x, and then we're left with the square root of b over a, but not just the positive version, the negative version, because if we take the square root of 25, it's not just 5. It's also negative 5. There's two possible answers because 5 squared obviously is 25, 5 times 5. But negative 5 squared is also 25. Negative times a negative is a positive 25. So we have to include both the positive and the negative version of it. Okay, and that's what this is saying. So let's look at example 1. Let's see visually what this looks like, and then we'll talk more algebraically as we go. So we're going to solve this equation, 2x squared equals 8, by two means. First by graphing, and that's visually going to show you why this is happening, and then also by using algebra. So first, let's graph it. So I'm going to make a quick XY chart to help me graph this. And I'm actually looking at this equation like this. Okay, 2x squared equals y. If I'm going to go ahead and I'm going to graph this, and I'll just throw it in here. So 2x squared. Just taking a look quick on the graph. Of course, it's going to be a parabola. You can see it's going to hit at 0, 0. So if I go to my table, if you look, going all the way to 32 and 18, those aren't really going to help. Here's my 8. Here's my other 8, but I want to see what this looks like on the graph. So I'm just going to go to those points. So negative 2, 8, negative 1, 2, 0, 0, positive 1, 2, positive 2, 8. Let's see what this looks like on the graph. So here's 0, 0, 1 and 2, negative 1 and 2, and then 2 and 8. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And the next one will be way off the graph. So there's what we've got there. It's going to be way up here somewhere. And try not to make a point at the bottom of your parabolas. They are curved, so they don't come to a point. It is a little bit like the side of a circle. There's a curve there. Only absolute values are going to come to a point like that. Now, we want to know, when does this equal 8? And so you're going to look at y equals 8. When does the y become 8? And so if we drew the line y equals 8, that's going to show us our two solutions, this one and this one. So it's when x equals negative 2 and positive 2. You can see it right here and right here. So it's the point negative 2, 8, and it's the point 2, 8. So two possible answers because it's a parabola. So anytime we have an equation in this form, you can see there's going to be two possible answers unless we're hitting the vertex, or there's no possible answer because we're not getting anything. Like, when is this negative 5? It's never. There's no answer. When is it 0? Just at 0. But when is it 8? It's at negative 2 and 2. And for any other positive number here, you're going to have two possible answers. So let's do it with the algebra now. So let's just solve this. So 2x squared equals 8. How do I solve this? So first, I'm trying to get x by itself. So divide by 2. This will go away. So x squared equals 4. To get rid of a square, you take the square root. So now I have x equals, so the square root of 4. It could be 2. 2 times 2 is 4. But it also could be negative 2. because negative 2 times negative 2 is also 4. And so my answer is positive or negative 2. And so you can say x equals 2 and negative 2 in a list, or you can just say plus or minus negative 2. Those are the two spots that this equation has a value of 8. Okay, so that's kind of visually, you can see why there's two answers. So when we take the square root, we got to remember to put both the positive and the negative version. And now we're going to go ahead and apply this to some word problems. So example number 2, a quarter is dropped 60 feet from the roof of a school. How many seconds will it take the quarter to fall to the ground? So for this, we need to use our equation that we started using yesterday. Galileo actually found this equation, and it estimates the distance something travels when it's dropped over a certain number of time. So its distance equals 16 times t squared. Okay, this is an equation that we're going to have to memorize. So when something is dropped, the distance equals 16 times the time squared. All right, so distance becomes 60, and we're trying to find out how many seconds it takes. So we're trying to find t. So let's solve it. Divide by 16. .75 right on the dot, so we can use that number. And that's t squared, so we want to find just t. Okay, so we're going to square root this, and we're going to square root 3.75. Now we're estimating, we're going to round this. 1.93 kind of goes up to 94. So we're going to say t is approximately 1.94. This is seconds. Now you may say, well, I thought you said it has to be a positive and a negative. Well, in a general sense it does, but this is talking about t representing seconds. And so can we have a negative seconds? And obviously the answer is no. So it also depends on the circumstance that you're dealing with. Sometimes only the positive makes sense. Flip it over. I want you to pause the video and try number 3. Same exact thing. So use that same formula when something is dropped. D equals 16t squared. Try this one, pause the video, then come back and see how you did. So we are plugging in once again for distance. So it's 1127 equals 16t squared. We're going to divide by 16 to get rid of it. So 1127 divided by 16. We got 70.4375. Go around it. All right, we're going to take the square root here to get it by itself. Fastest way to do that in your calculator, you hit square root, scroll up, hit enter, it throws it right in there for you. We're going to round this. 8.39 looks good. Seconds. And again, we do not need the negative version in this sense. The square root of this does have a negative version, but since t is specifically dealing with time, we're not going to have a negative amount. All right, so going to example 4. These are just straight algebra, so that means we can have negative amounts. This isn't pertaining to anything specific that wouldn't make sense to have a negative. So we want to solve this for n. We want to get n by itself. So this is kind of complicated here. Some people may want to distribute here, but you can't do that because you've got the exponents. And remember your order of operations, exponents come first. So you can't go ahead and distribute this because then you would be doing multiplication followed by exponents, which we know is not correct. All right, so we want to kind of isolate this kind of squared stuff on its own so that we could take a square root. Because right now, this squared is only going to the inside of parentheses. It's not on the 3. This is not a 3 squared. So I can't just take the square root. I could, but I'd have to take the square root of 3, and that's no fun. So here's the best way to do this. This is actually two things being multiplied. 3 times all of this. 2n minus 11 squared. 3 times that. So anytime you want to get rid of a number that's just being multiplied, you're allowed to just divide by that number. And so that's going to reverse this. So I still have 2n minus 11 squared. And 75 divided by 3 is 25. Okay, now this works out nicely. It doesn't always happen like that. But if I want to get rid of now a square, just like if this said x squared equals 25, how do I get rid of the squared? I take the square root, and the square root just knocks off the square because this is squared, and now you want to take the square root, it just goes off. So now I'm left with just 2n minus 11 equals. Now, the square root of 25 has two possible answers, 5 or negative 5. And 2n minus 11 equals negative 5 is different than 2n minus 11 equals positive 5. So there's two possible answers here. I could do the math here with the correct n, square it, and get 25 because this was a negative, or a positive 5. So what I have to do is I actually have to solve two separate problems here. So first I'm going to do 2n minus 11 equals positive 5, and then I'm going to do 2n minus 11 equals negative 5. You have to solve it twice. There's two answers here. All right, so the first one, nice and easy. N equals 8. Over here, n equals 3. So these are your two possible answers. N could equal 8. N could also equal 3. If you went back to your original and you plugged in 8 and ran it correctly with the order of operations, both sides would come out equal to 75. And if you plugged in 3, the same thing would happen. And the reason is, when you plug in the 3 or you plug in the 8, and then you run the inside here, it's going to come out to the positive and negative version of each other. And when you square it, they both become the same number. So let's pretend, well, we already know what this is going to become. This has to become 25, because 3 times 25 is 75. So something squared gave me 25. So this in here is going to be a 5. So if you plugged in 8, 2 times 8 is 16 minus 11, you'd get 5. 5 squared is 25 times 3, 75. So that clearly works. But if you plugged in 3, 2 times 3 is 6, minus 11 is negative 5. Well, negative 5 squared is positive 25. 25 times 3 is 75. So these two numbers create the 5 or the negative 5 that when you square it, both become 25, so that when you times it by 3 gives you 75. So that's why there's two answers there. All right, how about this one? Now you've got more than one thing being squared. And so before we start trying to square a root or anything like that, we kind of want to get things together. So just like if this was just an x on both sides, you'd move one of them so you can put them together. We're going to do the same thing. And just like before, when you look at those coefficients, ideally you want to keep things positive, so you're going to get rid of the smaller of the two. So I'm going to minus 3x squared from both sides of this equation. And so I'm going to get 4x squared minus 15. I want to isolate this as quickly as possible, so I'm going to go ahead and add 15 and get it on this side. Okay, and now at this point, I would divide by 4. $25 divided by 4 is not going to be a perfect number. 6.25. And now, I got to take the square root of this so that I have just x. And remember that this could have been a positive or a negative, so we got to keep that in mind. So we're square rooting 6.25. And it's 2.5. Now, this is positive or negative 2.5, because whatever the x is squared gets you this. So it could have been positive 2.5 squared or negative 2.5 squared to get me this.